Example 17 students, prove that tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta is equal to 1 plus sec theta cosec theta. So let us start to solve this example. Okay, first here we write the LHS. Okay, so here LHS is equal to tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta. So now here students we simplify this example. That is the tan theta means the sin theta upon cos theta. Then here 1 minus cot theta, that is 1 minus cos theta upon sin theta, plus here also cot theta, that is the cos theta upon sin theta, and here 1 minus sin theta upon cos theta. So now here that simplify this, that is the sin theta upon cos theta divided by cross multiply it sin theta minus cos theta upon sin theta plus here that cos theta upon sin theta. So here divided by after cross multiply cos theta minus sin theta upon cos theta. So here students that write the numerator first. Numerator is sin theta upon cos theta and the reciprocal of this denominator. So sin theta upon sin theta minus cos theta. Then here also first write down the numerator cos theta upon sin theta multiply the reciprocal of the denominator, that is cos theta upon cos theta minus sin theta. Okay students, then here then multiply this sin square theta. Okay, then divided by cos theta multiply sin theta minus cos theta. Then here plus, here also multiply cos theta, that is cos square theta and divided by sin theta multiply cos theta minus sin theta. Now here see students, both the denominators are different. So here we cross multiply. That is a cross multiply sin cube theta multiply cos theta minus sin theta. And here also students, that is cross multiply cos cube theta multiply sin theta minus cos theta. Okay, and divided by here cos sin theta multiply cos theta multiply sin theta minus cos theta. Then here in the second bracket cos theta minus sin theta. Okay, here is the cos theta minus sin theta, here is sin theta minus cos theta. So here we change the sign. Okay, we change the sign, and here also sin theta minus cos theta and cos theta minus sin theta. So we change the sign, and then afterward that minus 1 come at the numerator and denominator, then it will be cancelled out. So here that LHS is equal to sin cube theta multiply cos theta minus sin theta minus cos cube theta in the bracket cos theta minus sin theta, and then divided by here that sin theta cos theta in the first bracket we write cos theta minus sin theta, cos theta minus sin theta, and in the bracket second cos theta minus sin theta. Okay, so now here students, that is a cos theta minus sin theta here, and here is also. So it will be common out cos theta minus sin theta. Okay, right in the first bracket, and the second bracket we write the remaining term, that is the sin cube theta minus cos cube theta. Then divided by sin theta multiply cos theta, the cos theta minus sin theta divided by cos theta minus sin theta. Okay students, so now here cos theta minus sin theta, cos theta minus sin theta, get cancelled. Now here the remaining term is sin cube theta minus cos cube theta. So we here expand it. So the formula becomes sin theta minus cos theta. Then in the bracket sin square theta plus sin theta multiply cos theta plus cos square theta. Then divided by sin theta multiply cos theta, and then in the bracket cos theta minus sin theta. Okay, so now here students, that is the sin theta minus cos theta, and here cos theta minus sin theta. So here it will be cancelled out when we take the sign of minus outside. So here it will be cancelled out. I take the minus sign here. So now here I rearrange the term in the second bracket sin square theta plus cos square theta, then plus sin theta multiply cos theta. Okay, and here sin theta multiply cos theta. So now here sin square theta plus cos square theta, we know the identity, that is equal to 1. So plus sin theta multiply cos theta upon sin theta multiply cos theta. So here 1 upon sin theta multiply cos theta plus sin theta multiply cos theta, then divided by sin theta multiply cos theta. Then here separate out these. So 1 upon sin theta multiply 1 upon cos theta and plus 1. So 1 upon sin theta means students cosec theta, and 1 upon cos theta means the sec theta plus 1. So here that means the 1 plus cosec theta multiply sec theta, and which is equal to RHS. So here students, the LHS is equal to RHS. So hence proved. Example 18 students, prove that 1 upon cos A minus cos A, 1 upon sin A minus sin A is equal to 1 upon tan A plus cot A students. Okay, so now let us see how can we prove this theorem. That is a 1 upon LHS. First we write LHS, that is 1 upon cos A minus cos A in the first bracket student, in the first bracket. Okay, and then here in the second bracket 1 upon sin A minus sin A. So now here students, the simple thing that we have to simplify this, whatever we have to do it. So 1 minus cos square A, that is a cross multiply. So here cos A. Okay, now here students, here also cross multiply 1 minus sin square A upon sin A. So now see here, this will be the identity comes from the identity, that is a sin square A plus cos square A is equal to 1. So here that 1 minus cos square A is equal to sin square A upon cos A. And here students, that is the 1 minus sin square A, that is cos square A. So here upon sin A. So now here here sin A cancel, but here 1 sin A remaining. Here cos A cancel, but here the 1 cos A remaining. So here sin A, the answer is sin A cos A. Okay, this is the answer for the LHS. Okay, come from the LHS. Now here students are RHS. So the RHS is 1 upon tan A plus cot A. Okay, we simplify it. That is a 1 upon tan means sin A upon cos A plus here cot A means cos A upon sin A. So here students, that 1 upon, now here the denominator are different, so cross multiply. So sin square A plus cos square A divided by sin A cos A. Okay, so now here there is also the identity, that identity sin square A plus cos square A, that is 1. So 1 upon sin A multiply cos A. So now here student, see carefully, that is the 1 upon sin A into cos A. That means the sin A multiply cos A. So this answer comes from the RHS. So now here students see from the first and call it as the second equation. So first and second equation, that means from 1 and 2. From 1 and 2, we can say that LHS is equal to RHS. Okay, as LHS is equal to RHS, that means we prove. 19 student, so that example 19 is prove that cos theta minus 2 cos cube theta upon sin theta minus 2 sin cube theta plus cot theta is equal to 0. Okay, so let us first write down the LHS left hand side here. So LHS is equal to cos theta minus 2 cos cube theta divided by sin theta minus 2 sin cube theta plus cot theta. Okay, student. So now here that we simplify it, that is the cos theta, here cos theta, that common cos theta, then 1 minus 2 cos square theta. Okay, and denominator, there is a from denominator sin theta is common, so 1 minus 2 sin square theta, and plus here cot theta, students. So the cot theta we write as it is. First I write as it is, do not disturb it. Okay, cot theta. Now here that the 1 minus 2 cos square theta. Okay, students. So now here our identity is sin square theta plus cos square theta is equal to 1. That means here, students, the cos square theta is equal to 1 minus sin square theta. Okay, so here cos theta in the bracket 1 minus 2, and at the place of cos square theta I write 1 minus sin square theta. Okay, and divided by sin theta. So now here 1 minus 2 sin square theta plus cot theta. So now here that cos theta divided by sin theta, and here also that 1 minus 2 and plus sin square theta. Okay, and here 1 minus 2 sin square theta. Here also 2 sin square theta because we multiply by 2 here. Okay, so now here that cos theta multiply that 2 sin square theta minus 1, and sin theta multiply 1 minus 2 sin square theta. Okay, so now here also write down cot theta as it is. Okay, cot theta. So now here that see here is a 2 sin square theta minus 1, and here is 1 minus 2 sin square theta. So change their sign here. So after changing the sign, that is the LHS is equal to, so cos theta, I write here cos theta upon sin theta separately, and multiply here minus 1 and then 1 minus 2 sin square theta, and divided by 1 minus 2 sin square theta. Okay, and plus cot theta. So here, student, cos theta, here that means of cot theta. Okay, cot theta, and 1 minus 2 sin square theta, 1 minus 2 sin square theta get cancelled, and here minus 1 sign, and plus cot theta. So here minus 1 multiply cot theta, that is minus cot theta plus cot theta. So that will be equal to 0, and 0 that means which is equal to the RHS. So LHS is equal to RHS. Hence it is proved. 20 students, prove that sin A plus cos A upon sin A minus cos A plus sin A minus cos A upon sin A plus cos A is equal to 2 upon 2 sin square A minus 1. So here, students, first we write the LHS. So here we write the LHS. Okay. So now here LHS is equal to sin A plus cos A upon sin A minus cos A plus sin A minus cos A upon sin A plus cos A. So now here we simplify it by the cross multiply. So here in the first bracket we write sin A plus cos A, this one, and in the second bracket this one, that is sin A plus cos A. Okay, here also plus, write down this one, sin A minus cos A. In the second bracket, write one, this one, sin A minus cos A, and divided by, totally divided by, that is in the first bracket, sin A minus cos A, and in the second bracket, that is the sin A plus cos A. Okay, so now simplify it. See here, sin A plus cos A, here sin A plus cos A. That means, students, sin A plus cos A whole bracket square, and here also sin A minus cos A, sin A minus cos A. That means sin A minus cos A whole bracket square. So here divided by, Now here this one is sin A minus cos A. This is the sin A plus cos A. That means the expansion formula A minus B in the first bracket, A plus B in the second bracket. So A square minus B square. That means the sin square A minus cos square A. So now here the expansion of these sin square A plus, here I write the cos square A plus 2 sin A multiply cos A. Then here students, that is the sin square A. Then here plus cos square A minus 2 sin A multiply cos A. So totally divided by here sin square A minus cos square A. So now here sin square A plus cos square A, that means the answer is, here I write the sin square A minus cos square A. So now here the answer is 1. So plus. Now here 2 sin A cos A and here minus 2 sin A cos A. So it will be get cancelled. And here also sin square A plus cos square A, that will be the 1. So here divided by, now here sin square A minus here cos square A. So now here we put here, also we can here at this step, we write that minus cos square A means 1 minus sin square A. Okay. So now here we simplify sin square A minus 1 then plus sin square A. Okay. So that means 2 upon 2 sin square A minus 1. Okay student. So see here which will be the RHS. So here LHS is equal to RHS. So hence it is proved. Example 21 students, given that sin theta plus cos theta is equal to x, prove that sin raised to 4 theta plus cos raised to 4 theta is equal to 2 minus x square minus 1 whole bracket square upon 2. Okay student, so here first that given that is sin theta plus cos theta is equal to x. So I write here that sin theta plus cos theta is equal to x. So now here squaring on both the sides, squaring on both the sides. Here squaring on both the sides. So here sin theta plus cos theta whole bracket square is equal to x square. So square of this, that is the sin square theta plus cos square theta plus 2 sin theta multiply cos theta is equal to x square. So now here we know that sin square theta plus cos square theta, that means the 1. So I write here 1. So plus 2 sin theta multiply cos theta is equal to x square. That means students 2 sin theta multiply cos theta is equal to x square minus 1. And that means students sin theta multiply cos theta is equal to x square minus 1 upon 2. Okay. Now here I got the value of sin theta multiply cos theta. Now here I use, here next that I use the identity. First identity sin square theta plus cos square theta is equal to 1. Okay, I am squaring on both the sides. I am squaring this identity on both the sides. Squaring on both the sides. Okay. So now here, after squaring on both the sides, see here, I write here sin square theta plus cos square theta whole bracket square is equal to 1 square. So that means here sin raised to 4 theta plus cos raised to 4 theta plus 2 sin square theta multiply cos square theta is equal to 1. Okay student. So now here that the sin square theta, I write that sin 4 theta plus cos raised to 4 theta plus here, so here I write 1 minus 2 sin theta multiply cos theta whole bracket square. Okay, here I first we write the that is a transformation, that is sin square theta or cos square theta. Only transfer this term, and then afterward it simplify 1 minus 2 sin theta multiply cos theta whole bracket square. Okay, first transfer it that term and then square out. Then here 1 minus 2 and here sin theta into cos theta, that will be the x square minus 1 upon 2 whole bracket square. Okay, which is equal to 1 minus 2. Now the square of this. So I only write, okay, good. Here the our answer is x square minus 1 whole bracket square and here 2 square. Okay. Okay, so here 1 minus, so here 2 ones are and here 2 only. So x square minus 1 here and upon square on 2. So that means here we can simplify further, that is the 2 minus x square minus 1 whole bracket square upon 2. Okay, so this will be the sin raised to 4 theta plus cos raised to 4 theta is equal to 2 minus x square minus 1 whole bracket square upon 2. Hence, it is proved.